just cover it up in 2-3, I guess maximum 5 lectures, and then we can move on to the third chapter, which is pipelining and parallelism. So moving on, I guess I discussed a bit of it last time. Yes, I told you the basic characteristics of the processor. This is a RISC-based processor, has a simple load store architecture, supports pipelining. Then it has 32 GPRs, 32 FPRs. The data that it can support is either integer. This integer can be 1 byte of data, 16 bits, which is a half word of data, or can be a 32 bit, which is a word of data. So in one go, the maximum, the word length of this processor was 32 bits, but obviously it has the capability of leaving the other spaces vacant and working on just 16 bits of data in one go, or maybe 8 bits of data in one go. So it can operate upon a byte, it can operate upon a half word, it can operate upon a word. Next, what we were discussing was the floating point or the decimal point values. The RISC-based TLX processor has a capability of working on single precision as well as double precision numbers. So 32-bit in one go will be a single precision number. And if we take 64-bit and use floating point registers in pairs, we can work on floating point data as a double precision data also. Then memory, every memory location in this processor is byte addressable. Every address that comes for each memory location is 32 bits long in one go. And then the data was stored in big endian mode, right? Then, no doubts, the memory was byte addressable, but it was the opcode that defined what operation had to be carried out. So maybe if it is an operation of the kind load word, this will access 4 memory locations consecutively in one go. I'll come to it in detail today, right? यहाँ तक ठीक है सबको? Is there any doubt till here?
No, ma'am.
No, ma'am.
Speaker. I guess now you will hear better. So then we were discussing that what was big endian and what was little endian. Again, just two ways of storing data into the memory. If we store the least significant byte at the lowest address, byte of the data, at the lowest address in the memory, we say it is a little endian mode, which was usually followed in CISC-based machines. While if we store the most significant byte of the data at the lowest address, we name it as big endian mode. Although the data does not change, it is just the processor's convention of storing and retrieving data. So let me repeat it again and again, that whenever we talk about any data, the data will never change. ये सिर्फ एक तरीका है डाटा कैसे स्टोर हो रहा है मेमोरी में या रजिस्टर्स में और कैसे रिट्रीव हो रहा है. That's it. Only for processor's convenience. This is where we left last time. So we all know that every instruction has two parts. We have the opcode and we have the operand. What is an opcode and what is an operand?
Ma'am,
opcode is the instruction which needs to be performed, and operand is the registers or the data on which the operation needs to be performed.
Right. So if we talk about the opcode, it is the job part of the instruction, what we want the instruction to perform. And operand is the data on which the instruction needs to perform certain operation. Then how we specify the operands in any instruction actually is the addressing mode of the instruction. I hope that's clear to everyone. हमने ऑपरेंड्स को इमीडिएट लिया है तो इमीडिएट एड्रेसिंग मोड हो गया. अगर हमने ऑपरेंड्स को रजिस्टर्स में लिया है तो रजिस्टर एड्रेसिंग मोड हो गया. अगर ऑपरेंड को मेमोरी से लोड कर रहे हैं और मेमोरी के बेस्ड डिस्प्लेसमेंट वाला यूज कर रहे हैं तो इट्स बेस्ड डिस्प्लेसमेंट एड्रेसिंग मोड एंड सो ऑन, right? So the way we express the operands in any instruction is actually the addressing mode of that instruction. So basically, when we talk about this TLX processor, this has 5 main addressing modes. The first one, can you see my screen? I don't know, this is hung up.
Yes.
Okay, fine.
It is visible.
Okay, now when we talk about the first one, this is a register-based addressing mode. As the name signifies, the operands should be now available in the registers, right? So registers, if we take an example, say add R1, R2, R3. Having studied the ARM processor, I guess you will be aware of such instructions earlier only. So what will this instruction do?
Ma'am, this instruction will add R2 and R3 and store the result in R1.
Very good. So the contents of R2 and R3 are added up and the result gets stored to register R1. Now since we have both the operands in the registers, this is a register addressing mode, right? The next addressing mode that this DLX processor supports is the immediate one. Now the same instruction, I should have written add immediate here. One I will come. If I can just make a change right now. I did not realize. I'll just try it right now. So we add immediate. Okay. So yes, if we see the add immediate addressing, the immediate addressing mode, the example that I've taken up here is add immediate R1, R2 hash 0013H. Anyone who can tell me what is the instruction doing?
Ma'am,
Nirmati.
okay. Ma'am, so the instruction will take up the values जो 13H in hexadecimal and add that value to the value in register R2 and the result will be stored in the register R1.
Very good. So now why the name is immediate, why this name immediate is given is because one of the operands is immediately specified in the instruction. So if you will see, the instruction says add immediate R1, R2 hash 0013H. So 0013 is a 16-bit number in hexadecimal. So any number that has to be immediately added to the contents of register R2 and the result gets stored into the register R1. अब बाकी रजिस्टर हैं पर एक ऑपरेंड आपका इमीडिएट है, इसलिए इमीडिएट एड्रेसिंग मोड इज द नेम व्हिच इज गिवन टू इट एंड फॉर अ रजिस्टर ऑल द ऑपरेंड्स विल बी अवेलेबल इन द रजिस्टर्स ओनली, राइट? Okay, moving down, the next one is a displacement addressing mode. Now see, this addressing mode is normally used with loads and stores. I have taken up an example to explain what is a displacement addressing mode. So if I just say this is load word into R1, comma 2340 bracket R3. अच्छा, आपने अब ARM प्रोसेसर पढ़ा है. What is this 23401? What is bracket R3? नहीं? रोहन?
नहीं पता.
Reference to R3.
हाँ, तो जो रजिस्टर जब भी हम ब्रैकेट लगाते हैं ना किसी रजिस्टर के अक्रॉस, we put a square bracket. This means that this is a memory location now, right? So whatever are the contents of R3, the 32-bit value in R3 is now treated as a memory location. But not just R3. It is R3 plus 2340. Okay, yeah. So it is R3 plus 2340 is the final address of the memory. Let's see if I can write this down. So if we just see, now into the memory, we will find the total location as the contents of the base register. What is the base register here now?
R1.
R3. R3. R3 is the base register.
Okay.
And because see, we have to calculate the address of the memory, right? So this says load word into R1 from 2340 plus R3H. And this will be the entire memory location that you have to refer, right? The name displacement comes from the fact that, or we can call it base displacement also. This is also referred to as base displacement. So we have a base register R3 here, some value it contains, and 2340 is the displacement from that base of that memory location. So contents of the base register plus the 16-bit displacement given in the instruction. इससे टोटल मेमोरी लोकेशन का जो एड्रेस बनेगा उस मेमोरी को एक्सेस करेंगे. ठीक है, तो अब अगर मेमोरी एक्सेस करेंगे तो सपोज ये वाली मेमोरी बनती है, maybe this location, right? And say this location will be identified as 2340, sign extended and added to the contents of R3. So whatever value that comes out after adding 2340 plus R3, and that value is actually a content of is actually the location of a memory. So that location is accessed. Now it says load word. So it should load. There is a chat message. Ma'am, please explain this again. Okay, let me just let this off. R3 contains 1009 the AF100 right. Suppose now see the name the base displacement byte is given. ये इंस्ट्रक्शन हम डिटेल में पढ़ेंगे जब हम लोड स्टोर इंस्ट्रक्शंस पढ़ेंगे, but right now just for your information this base displacement addressing mode it is used with load and store operations. ठीक है, whenever we have to access the memory, so all the load and store operations they use base displacement addressing mode. ठीक है, अब इसमें क्या होता है, we have a base register, so right now R3, this contains some value. The value of this register is added to the offset or the displacement that is referred to in the instruction. Adding the two, we get any 32-bit value. That 32-bit value corresponds to our memory location now. So I am just writing it down. So this becomes 2340, and whatever resultant you get. So whatever is the resultant, (32-bit value), this is now treated as a memory location. I hope it's clear now. I hope it's clear. Now, in a base displacement addressing mode, we have a base register and we have a displacement value specified in the instruction. Since it is a RISC-based architecture, all the operations to the memory and from the memory can only be done with the help of load store operations. So all load store operations are implemented using the base displacement addressing mode only. Okay? How this operates? This says load word into R1 from a memory location which is computed as R3 plus 2340. By default, we call the register which is there in the instruction as a base register. So maybe R3 contained 1009 and AF10H, any 32-bit value. Then we have mentioned a displacement. A displacement, say suppose R3 points to this location. I'll just draw it for you. Say suppose R3 contents point to this location in the memory, for example, right? And then the data has to be picked up somewhere from here, say from here. And the distance between them in terms of locations, offset, turns out to be, say this is 2340, right? समझ आ रहा है सबको?
Yes.
Now we have to load the data from here, right? So we want to pick up a word of data starting from here and load it into a register which is R1 right now. We'll do this again in the instruction set also, just to let you know. Okay, right? So I will give an instruction, load word into R1 from base register R3 plus 2340H. तो ये location बन गई. Are you all getting it?
Yes, ma'am. Yes, ma'am.
Okay. So from this location, the data is now picked up and stored in register R1. But this operation, the operation of load word, yes. So this operation of load word identifies how many locations of memory you have to pick up for loading R1. ठीक है? अब आप मुझे बताएंगे, आप लोग बताएंगे कि इसमें कितनी locations access होंगी memory की. For this instruction, how many locations of memory will be accessed consecutively?
3.
Including this one 4 and above this one 3, है ना? तभी बनेगा ना 32. One location is 1 byte, so 8 4 is 32. ठीक है? So 2340, 2341, 2342 and 2343 चार लोकेशंस का डेटा उठेगा, R1 में बिग एंडियन मोड में लोड हो जाएगा. ये हम डिटेल में भी करेंगे आने वाले टाइम में जब हम इस इंस्ट्रक्शन पर पहुंचेंगे. यहाँ तक क्लियर है? व्हाट इज द डिस्प्लेसमेंट एड्रेसिंग मोड?
Yes, ma'am.
Alright. Okay. So moving on, the next type of addressing mode is just a variation of the displacement addressing mode only. If you will just see here, I have taken an example of store word. This says store word from R2 to a memory location which is identified as 0 plus R3. Now what is the base register here?
R2.
R2.
R3 again. जो भी memory को refer करता है उसको base कहते हैं, ठीक है? So R2 is the source. It is the source and this is the destination that we have to refer to. And how do we compute the destination? It is the base register plus the displacement. Now see, can you identify some difference between 2340 R3 and 0 R3? Forget about the instructions, just tell me about the memory computation. This is 2340 bracket R3 and this is 0 bracket R3. क्या difference है?
हाँ वो रजिस्टर
Ma'am, in the
हाँ रोहन, you speak up.
I'm not sure, I guess वो रजिस्टर को ही एक्सेस कर रहा है ना 0 R3 को.
हाँ ठीक है. निर्मति, you speak up.
मैम जो फर्स्ट प्रीवियस वाला इंस्ट्रक्शन था उसमें हम R3 में 2340 लोकेशन प्लस मतलब इतना एड्रेस और ऐड कर रहे थे. फिर जो हमारे पास रिजल्टिंग एड्रेस आ रहा था उसको हम एड्रेस कर रहे थे. बट जो हमारे पास ये वाला इंस्ट्रक्शन है इसमें हम कोई भी एड्रेस और ऐड नहीं कर रहे हैं, हम R3 वाले एड्रेस को ही वो करना चाह रहे हैं.
Yes, absolutely correct. Now, if I am referring to R3 as the base value, this R3 itself is a memory location. The contents of R3, which was the base value, is itself a memory location. I am not adding any offset to it, if you see. So in the previous diagram, if R3 referred to the base value of the memory, I am right now accessing this memory location only. Another way of referring to memory, just a variation of the base displacement addressing mode. Okay? So what will this instruction do? This will take the contents of R3, add 0 to it, so there's no displacement, right? So it will take R3 as a memory location, contents of R3 as a memory location, access the memory and store the contents of the source register R2 at that memory location. Clear everyone?
Yes ma'am.
मैम आई हैव अ स्मॉल डाउट. मैम इसमें अगर हम यहाँ पे 0 नहीं लिखेंगे तो भी चलेगा या फिर इट इज रिक्वायर्ड टू स्पेसिफाई?
No, you don't need to specify. अगर यहाँ नहीं कुछ लिखोगे वो automatically 0 identify हो जाता है.
Okay.
So just for your convenience, I have written 0. If you don't write 0, it will be automatically in the instruction encoding format, it will taken as a 0. Okay. Okay. Moving on.
Can we write R3 without brackets?
No, you will have to write R3 with a bracket because this is the syntax. A syntax error, I hope you know, will not allow your program to run. तो जो syntax है instruction का उसको ignore नहीं कर सकते, वो हमें follow करना पड़ता है. So you have to write a bracket. Okay. The last one is the absolute addressing. Again, absolute addressing is also variation of the base displacement addressing mode. Anyone who can identify what is the difference now? Anyone who can identify the difference?
It is in respect to the R0 register, R0 register.
Does R0 have some specification? Was R0 some special register? No?
किसने कहा तो उससे WhatsApp log out करने वाले तो
Like
R0 is fixed to 0.
R0 is Riya, please mute yourself. Okay, I'm muting everyone so that only the ones who want to speak can unmute and speak up. There is a lot of disturbance. Okay, so for an absolute addressing, the only difference between an absolute addressing and a base displacement addressing is that the base register here is taken as R0. And R0 is a special register whose value is fixed to 0. So what is your memory location now, which you are referring to?
0 offset 1306.
बिल्कुल 1306. इसका मतलब ये है कि when we start with addresses and we are starting from 0, then 0001, then 0002, 3, 4, 5, then 9, then A, then B, then C, and so on. तो हमारे पास ऑप्शन है कि अगर हमें 32 बिट एड्रेस के सिर्फ लोअर लोकेशंस को एक्सेस करना हो, लोअर एड्रेसेस को एक्सेस करना हो, तो हम ऐसे भी कर सकते हैं. दिस इज अगेन अनदर वे ऑफ representing the memory, right? Otherwise you always have an option, you can put the smaller value into a register and then access the register, so there's no problem. All right?
तो इसमें आपने ऑफसेट दिए हैं मैम, ये सारे डेसिमल है ना, मतलब
हाँ सब डेसिमल है, हम सब इंटीजर्स की बात कर रहे हैं फिलहाल, सब डेसिमल की बात हो रही है. एक मिनट, योर क्वेश्चन इज कि इंटीजर है या आप पूछ रहे हो कि हेक्साडेसिमल है या डेसिमल है?
हेक्साडेसिमल या डेसिमल?
नहीं, ये हेक्साडेसिमल है. शरणप्रीत,
जो ऑफसेट है 13, जैसे 13
everything is in hexadecimal. So when we do assembly level coding, every data that we represent is in hexadecimal by default. ये आपको याद रखना पड़ेगा accordingly. So if you have to write 10, you have to write A, 0AH. Okay. Well, I guess we will not be going into those details because our main motive of studying this course is not to go into the coding and assembly level programming. Our main crux of in a nutshell, why are we studying this course? Because you should know about the higher end DSP processors which are there in the market. इसके बाद आपको एक elective मिलेगा next year में, which is DSP processors. So if you will study that course, you will be kind of having a specialization in this field. तो आपने आर्म प्रोसेसर पढ़ लिया, उससे पहले आपने डिजिटल इलेक्ट्रॉनिक्स पढ़ा, फिर आपने आर्म प्रोसेसर पढ़ा, अब आप रिस्क बेस्ड DLX पढ़ रहे हैं. इसके बाद अगर आप DSP प्रोसेसर पढ़ेंगे तो आपका इस फील्ड में पूरी नॉलेज कंप्लीट हो जाएगी. तो जस्ट फॉर योर इंफॉर्मेशन, all the data is in hexadecimal. Well, we will not be going into those details. मैं वो सब आपको नहीं कराऊंगी क्लास में, क्योंकि मैं एक्सपेक्ट करती हूँ कि आपको अब तक आना चाहिए. Okay, moving on. Then when we talk about these instructions, all the DLX instructions in all are 64 in number. So we have total of 64. I'm talking about integer only. So only the GPR based operations. If we talk about those operations, they are 64 in number. Every instruction is also encoded as a 32-bit information into the processor. When it goes to the processor, it goes in form of ones and zeros, right? So we all know We are writing assembly level codes only for our convenience. When the processor, when the CPU fetches the instructions and decodes it, it is all a sequence of ones and zeros. So inside the processor, every instruction can be encoded into basically three types. The first type we have is the I type. Then we have an R type and then we have a J type. ठीक है? अब जिसको जो किसी को डाउट था अभी पीछे कि मैम जीरो लेंगे कि नहीं लेंगे, अभी मैं आपको बताती हूँ. So what happens in an I-type encoding? Suppose I've taken, see, all the instructions which are in the immediate addressing mode, which are referenced in an immediate addressing mode, the load and store operations, and conditional branches, and also jump register and jump and link register. So these are exceptional cases. ये मैं बाद में बताऊंगी जब हम instructions पढ़ेंगे. For the time being, you should all know that all immediate operations, all loads and stores and conditional branches, they are encoded using the I type. ये हम इसलिए पढ़ रहे हैं क्योंकि जब आप आर्किटेक्चर पढ़ेंगे वहाँ पे इंस्ट्रक्शन डिकोड होती है, कौन सी फील्ड कहाँ रीड होती है और कहाँ क्लैश होता है. You need to know. So this forms again a prerequisite of the next chapter. Right? Clear है यहाँ तक? Is it clear till here? Okay. So the I-type instruction encoding format, I have taken up an example. So we have, it's a 32-bit format in which we have 6 bits always identified for the opcode, right? We have 5 bits for register source 1, 5 bits for the destination register, and 16 bits for the immediate field which is there in the instruction. For example, if I take the load word instruction, this says load word into R1 from 1345 bracket R2. What is the opcode here?
LW.
Yeah, the load word, right? So LW is encoded into 6 bits and is stored here as a code for load word, right? The register source 1 and destination, and then we have the immediate field. Now by default, the 16-bit data which is there in the instruction is 1345. So the 16 bits of the immediate data in the instruction is encoded here, right? अगर अब यहाँ कुछ नहीं होगा तो by default यहाँ क्या आएगा? जीरो आ जाएगा. तो जीरो लिखना जरूरी नहीं है इंस्ट्रक्शन में, अगर हम नहीं भी लिखेंगे तो उसने ऑटोमेटिकली जीरो उठा लेना है. ठीक है? So this is what I was saying in the previous slide. So immediate field encoded as 16 bits here. Now we are left with two things. One is the instruction says load word into R1 from 1345 plus R2. What is the source and what is the destination?
RS is source and RD is destination.
No, in your instruction, the example instruction that I've taken, which is the source and which is the destination?
Ma'am, the destination is R1.
Very good.
And the source is R2 plus 1345 की memory location.
Very good. So right now, the 1345 part has already been encoded. The cursor, yeah. So 1345 part has already been encoded into 16 bits here. And the R2 is encoded as 5 bits here. The destination register is R1, which is encoded here into 5 bits. I hope this is clear now. You just need to remember this because while we will be doing the pipelining, you will come to know what clashes with what. So that time you need to remember this. ठीक है? ये एक बारी आप लोग देखेंगे आपको याद हो जाएगा. Should I move on?
Yes, ma'am.
Okay. So the next type of encoding that we follow is the R type. Now all the register based addressing mode operations wherein all the operands are in registers uses this type of encoding format. For the R type encoding, we have 6 bits of opcode and 11 bits of function. Together, they represent the operation that the instruction has to carry out. If I am I just have a question for you all. if I'm using 6 bits for the opcode, how many combinations of the opcode are possible?
32.
64
64.
64.
64.
64 ऑपरेशंस
64
पॉसिबल हैं, ठीक है। अब उसमें कुछ इमीडिएट हैं, कुछ एक्सेप्शनल हैं, कुछ आपके पास स्पेशल रजिस्टर्स वाले भी हैं। तो हम क्या करते हैं, या जो इसका हार्डवेयर ऐसा डिज़ाइन है कि इसमें ऑपकोड सो इसमें जो ऑपकोड है, ऑपकोड प्लस फंक्शन बिट्स, total 17 bits are used to identify the R-type operation. This is just done to make a distinction. So otherwise opcode will always occupy 6 bits, but in an R-type operation the function bits also play a role. So 11 bits of function and 6 bits of opcode are together used to identify what operation the instruction is going to carry out. Clear? अब एग्जाम्पल ले लेते हैं।
आप इसमें R टाइप में फंक्शन का एग्जांपल
इसमें actually we don't have to go in for, see if you will see these 11 bits, these have 2 raised to the power 11 combinations, right? उसमें से कुछ combinations हैं जो R type operations के साथ use होते हैं append करके। So suppose we have add operation, add का एक specific code है, उसके आगे एक combination इस 11 bits का लगेगा, and then the processor identifies that this is an R type add operation. But we don't need to go in those details. We don't need to go because this is none of our concern. Our main concern is the basic programming and coming to the pipelining. Okay? So moving on, if I just see this R-type operation encoding is basically used with all register type ALU operations. So जितने भी, as I told you, जितने भी हमारे register type addressing mode के operations हैं, वो सब R-type encoding format follow करते हैं. Some read write and special of some special registers and move operations also use R-type encoding. So this is why they have used 11 bits of function. Though you will not find, say this is a machine encoding. We don't need to read it also. Just that we should know. As an engineer, we should be aware about it, that there is a library into which there are certain combinations stored. 2 raised to the power 6 combination correspond to the opcodes, and 2 raised to the power 11 combinations are for functions, right? So this the register type operations which are there, they append to themselves some combinations of the function to identify the operation that the R-type instructions are going to carry out, right? Taking an example, this is add R1, R2, R3. As one of you just said, this instruction is going to add the contents of R2 and register R3 and store the result into register R1. Now, how will this be encoded? The add will have a 6 bits of opcode which will be represented here. The cursor nazar aa raha hai sabko?
Yes,
Yes,
ma'am.
ma'am.
Okay. So now it is gone somewhere. Yeah. So 6 bits of opcode here. Now we have register source 1, 5 bits, register source 2, 5 bits, and destination register again 5 bits. You will tell me what will come where from the current instruction.
like इस स्लाइड पे ऐड R1 R2 R3 लिखा होगा.
Which is the
So-
source 1?
Yeah. So ma'am, R2 and R3 will be the source registers
Very good.
and R1 will be the destination.
Very good. So R2 is my source register 1. R3 is my source register 2. Accordingly, they have their own encoding formats. We don't need to discuss what they have, but we should know that they have something, okay? So R2 has its own code of 5 bits used here. R3 has its own code of 5 bits used here. And R1 has its own code of 5 bits used here. This is just a machine level encoding used by the processor to store the instruction into the instruction register. So into the fetch stage, we have an instruction register and a program counter. There these are used. So when the instruction is fetched, it is brought in, it is in this format, and this, as it is stored in the instruction register. And while it is decoded, executed, and written back, or maybe the memory is accessed, the respective fields are referred to by the processor to identify which is the source register 1, which is the source register 2, which is the destination register, what is the, in the execute stage, it comes to know what operation it has to carry out. So just for the reference of the processor. Clear?
Yes, ma'am.
बड़ा ढीला सा यस मैम था, नहीं समझ आ रहा है?
नहीं मैम आ रहा है.
Okay. Okay. So the third type of encoding that we follow for the DLX processor is the J-type encoding. So all your jump operations, jump and link, the trap, which is a software interrupt, and a return from exception. I'll tell you what these instructions are when the time comes. So you'll get confused if I tell you everything right now. So this is a software interrupt, and this is used to return from the interrupt subroutine back to the main program. So these instructions, all of these use J-type encoding. Now, if, for example, I have taken up a jump followed by a target. What is this target that I've written here? Jump is an unconditional jump instruction. It is always followed by a target. We have been writing this in the coding of ARM processor also. What is this target?
Ma'am, the target is the instruction to which this subroutine would have to go after it is completed, it is executed.
Okay, good. Partially, this is correct. I will just tell you that if suppose you are currently in a program and you want to, jump somewhere to any other location in the program, say maybe you are here right now, right? And here you write a code of, jump, say target, and say target is here. Say the target is here. So that time, what do you write down? Do you write the actual address, or you just write the offset or the displacement? You write the displacement. I don't know whether you've done this in the previous semester or not, but let me tell you that this is the offset that we mentioned, right? So offset is the same 1, 2, 3, 4 followed by bracket R2. So that 1, 2, 3, 4 was the offset of that load word instruction. Offset to the next memory location, displacement to the next memory location, the distance in terms of locations to the next memory location where we want to point to, right? So suppose I had a program where I had given, this instruction, jump followed by target. And this is an unconditional branch, so this has to take place in any case. So what happens? My program counter, when it fetches this instruction, decodes it, the program counter automatically becomes, क्या आएगा? What is a program counter?
एक बार लास्ट वाली लाइन रिपीट करिए.
मैं पूरा ही रिपीट कर देती हूँ. आप मुझे बताइए प्रोग्राम काउंटर क्या होता है?
अब वो एड्रेस स्टोर करता है.
हाँ.
Next instruction.
बिल्कुल. तो प्रोग्राम काउंटर में हमारे करंट इंस्ट्रक्शन का एड्रेस होता है. जैसे ही वो फेच होती है, ये पीसी प्लस नेक्स्ट इंस्ट्रक्शन के एड्रेस पे पहुंच जाता है. अगर इंस्ट्रक्शन की लेंथ 1 बाइट थी तो ये पीसी प्लस 1 हो जाता है ना? अगर इंस्ट्रक्शन की लेंथ 2 बाइट्स है तो पीसी प्लस 2 हो जाएगा. अगर इंस्ट्रक्शन की लेंथ 4 बाइट्स है तो पीसी प्लस 4 हो जाना चाहिए ऑटोमेटिकली, क्योंकि मेमोरी में आपके पास सिर्फ 1 बाइट एक लोकेशन पे स्टोर हो सकती है. So suppose we have this code and we are executing this code which is here, right? मैं पूरा repeat कर रही हूँ. So this is the code and we are executing the code. We come here. The program counter fetches the jump instruction. It decodes the jump and program counter automatically upgrades itself to PC plus the next instruction. So it points to the address of the next instruction in sequence. Since every instruction is 32 bits in length, this becomes PC plus 4 क्यों हुआ 4?
32 bits तो
Yes, because 8 fours are 32. One location is 1 byte, 8 bits. I have to fetch one instruction which is 32 bits. Means 4 locations. So automatically PC plus 4 हो गया. ठीक है? अब जब ये jump target instruction हमने decode करी और execute करी, तो execute करने पर क्या होता है कि target which is an offset which is a displacement, सिर्फ प्रोग्रामिंग में हम टारगेट लिखते हैं, जब कंपाइलर इसको कंपाइल करता है वो टारगेट की वैल्यू निकाल लेता है इन टर्म्स ऑफ डिस्प्लेसमेंट टू द टारगेट इंस्ट्रक्शन. ठीक है, तो this is called as an identifier which we normally use. So what happens when this instruction is decoded, it is executed, the address of the branch is calculated as PC plus 4 plus sign extended target. तो वो शायद ये है. ठीक है, अब इसको जब एनकोड करना है तो हम ये फॉर्मेट फॉलो करते हैं. जो 6 बिट्स का ऑपकोड है जंप का वो यहाँ आएगा. इट कम्स अंडर द ऑपकोड फील्ड and the offset which we see if 6 bits are gone out of 32, how much is left? 26. So now jump is the jump and unconditional branch of the type jump and link, trap and RFE. These are the 4 instructions which only have a provision of using 26 bits of displacement or offset in the instruction. ये सब डिटेल में हमने करना है जब हम इंस्ट्रक्शन सेट अभी पढ़ना शुरू करेंगे. So just for your information right now that while encoding the instructions we have 3 formats: I type used with all immediate operations, load store operations; R type used with all register type operations; and J type used with unconditional branches of the type jump, trap, jump and link and return from exception. अब ये क्लियर हुआ है? What I explained here, is it clear now?
Yes,
Ma'am,
ma'am.
basically the plus 4 here is the offset that we have added.
No, it is not the offset. See, I'll just tell you. This is very important, you must know this. See, what is a program counter? What is a program counter? It's a register.
So the
It's a special register which is there in the processor, which the processor has. This special register points to, or maybe stores the, I should write stores the, it stores the address of next instruction in the sequence. ठीक है, अब suppose
Yes, ma'am.
मेरा कोड कुछ ऐसे लिखा हुआ है. I'm not having a watch, just let me know when the time is over, okay? So suppose I've written my code like this. Say this is the load word into R1, comma 234 bracket R3H. Then I say suppose load word into R4 from 10 R3, and then I say and suppose then I say add R1, comma R4, comma R4, R1. Suppose this is the code, three line code that I've written. So how do I store it in the memory? Every instruction is 32 bits,
Yes, ma'am.
One memory location is how much?
8.
8 bits, 1 byte. एक इंस्ट्रक्शन को स्टोर करने के लिए 4 लोकेशंस लगेंगी.
Yes, ma'am.
लगेंगी ना. अब ठीक है, जब प्रोग्राम काउंटर है, जब ये प्रोग्राम एग्जीक्यूट होना शुरू करता है तो सबसे पहले क्या होता है, प्रोग्राम काउंटर को हम लोड करते हैं विद द एड्रेस ऑफ द फर्स्ट इंस्ट्रक्शन इन सीक्वेंस. ऐसे करते हैं, ठीक है. दिस गोज ऑन द एड्रेस बस. The address bus identifies the memory. Since it knows that every instruction is 4 bytes, it will pick up the data from 4 locations in one go. उठाएगा ना, तभी इंस्ट्रक्शन पूरी आएगी, नहीं तो इंस्ट्रक्शन तो आधी आ जाएगी फिर.
Yes, sir.
ठीक है. It puts it on the data bus, brings it inside the processor, and then decodes. By the time the contents of program counter should become
Going to the next.
Next one. Next one.
what, and what should be the next one now? I have
Plus.
accessed 4 locations.
+4.
वेरी गुड. बस ये आपके क्वेश्चन का आंसर आ गया. ठीक है.
Yes, ma'am.
तो
Yes.
प्रोग्राम काउंटर हर बार ऑटोमेटिकली +4 अपडेट हो जाएगा फॉर एवरी नेक्स्ट इंस्ट्रक्शन दैट हैज टू बी एग्जीक्यूटेड इन द सीक्वेंस. राइट नाउ this unconditional branch which is jump followed by a target, what this does, it takes the value of the current contents of program counter which is pc+4. जब जंप डिकोड हो गई तो पीसी तो ऑटोमेटिकली pc+4 हो जाता है. ठीक है. इट इज पॉइंटिंग टू द एड्रेस ऑफ नेक्स्ट इंस्ट्रक्शन इन सीक्वेंस. ये ऑटो अपडेट हो जाता है. वी डोंट नीड टू डू एनीथिंग. सो दिस pc+4 is added to the displacement and the branch address is calculated. So this is the branch address. This is calculated. This is calculated by adding pc+4 plus target. So this is what I was saying here, that your branch instruction, that your jump unconditional type is followed by a 26-bit offset and is encoded like this, right? So what happens when this instruction is fetched and decoded? The branch address is calculated as pc+4 plus this sign extended offset or the displacement or the distance between two instructions, consecutive instructions. I should not say two, the number of instructions which are there between your target. I'm just drawing it for you. Just a minute. Yes. So this one. ये सब डिटेल में करेंगे, आपकी सब डाउट्स क्लियर हो जाएंगी. अभी तो बस
Ma'am, actually we have a class.
Okay, I'm just finishing this up. So this is all for today, and next time we will start with the instruction set architecture now. All right.
Okay.
ठीक है बच्चे. Thank you everyone.